Hi, this is Swati, and in today's video we'll do some very important and repeated questions of chapter Circles class 9th. So these questions I've taken it from RD Sharma and RS Agarwal, and if you are very good at these questions, you will definitely crack circles. So in my previous video I've already explained you all the theorems, all the important points of this chapter. Go check it out and then see this video. You will definitely find easy to solve these questions. Now let's get started. The first one, if O is the center of a circle, find the value of x in each of the following. Now this is the x, right? Now this is my center, right? O is the center, so I can find this angle easily because they are forming linear pair. So angle AOC plus angle COB is equal to 180 degrees, linear pair. So angle AOC is 135 plus angle COB is equal to 180. So angle COB is equal to 180 minus 135, which is 45 degrees. Now I need to find this angle. Now this angle is formed by these two arms, right? By these two arms. So this is the center angle. We have a theorem that center angle is double the angle subtended anywhere on the remaining part of the circle. So this is my center angle. So this center angle is double the angle anywhere on the remaining part. Remaining part is this part. So on this part we have this angle x. So center angle is double of angle x. So this is way you can easily find x. So 45 by 2 is equal to x. Therefore x is equal to 22.5 degrees. Now the very important thing is you always need to try and figure out how is the angle forming, what is the source of the angle, by which two arms the angle is forming. So then it will be easier for you to apply the theorem. Next, you again need to find this x. So this is here and this is given as 40 degrees. Alright. Now O is the center. So if O is the center, I can say that this angle is 90 degrees. Angle DBC is equal to 90 degrees. Angle in semicircle. Correct. So if this is 40, this is going to be 50 degrees. 50 plus 40 is 90 degrees. This is 50 degrees. Now if I consider triangle BOD, I know that OD and OB are equal. OD is equal to OB because both of them are radii. So if the sides are equal, their opposite angles will be equal. So therefore x will be equal to angle DBO. So therefore x is equal to DBO is 50 degrees. So the value of x is 50 degrees. I hope this is clear. Now moving on, in the figure triangle PQR is an isosceles triangle. So PQ will be equal to PR. Angle PQR is 35. This angle is 35. We need to find angle QSR. So let me take this as X. And angle QTR. Let me take this as Y. So it's very important you write what is given to you, also mention in the figure so that it becomes easier to just look at the figure and answer. Now since we know PQ is equal to PR, therefore angle PQR will be equal to angle PRQ, because if the sides are equal in an isosceles, the opposite angles are equal. So both of them becomes 35 degrees. So from this I can find, now considering triangle PQR, I have two angles, right? I know Q, I know R. I can easily find angle P. So 35 plus 35 plus angle P is equal to 180 degrees. Angle sum property. Now So angle P will be equal to 180 minus 35 plus 35 is 70, which is 110 degrees. Now if we observe, angle P is forming using the same chord QR. Similarly, angle S, that is X, is forming using the same chord PR. So from this I can write that angle QPR is same as angle QSR, because angle in the same segment, both of them are forming using the same chord. So angle QSR is equal to 110 degrees. So this is one angle. Next, as we know that QPR and T, QPRT is cyclic because all the vertices lie on the circle. So in the cyclic quadrilateral, sum of opposite angles is always equal to 180 degrees. So angle P is 110 plus Y is 180. So Y is equal to 180 minus 110. What is angle Y? Angle QTR is equal to 70 degrees. So here I'm just figuring out how is the angle forming, how to approach the question. Next, now this is a different question. In a circle of radius 17 centimeter, two parallel chords are drawn on the opposite sides of the diameter. So let me just figure out this much. So two chords are drawn on the opposite sides of the diameter. This is my center. So let me take this chord as AB, this as CD, and the radius is given as 17. So this is again the radius 17. The distance between the chords is 23. Here the distance is 23. This is my center. If the length of one chord is 16, so I can take AB as 16. You need to find the other. So basically we need to find CD. So let me name this as M and N. Alright. We have learnt a theorem that when you drop a perpendicular from the center to the chord, it bisects the chord, right? So if AB is 16, each is going to be 8 centimeter. Correct? Alright. Now, how do we start? So if I take OM to be X, ON is going to be 23 minus X, right? Because the total sum is 23. Now to find CD, if I figure out ND, the double of ND will be CD because CN equals ND. The line that is perpendicular dropping on the chord is always bisecting the chord. So to find ND, we need to first figure out X. So I can consider this triangle. So in triangle OMB, applying Pythagoras theorem, OB square equal to OM square plus MB square. So whenever you have a right angle triangle, always apply Pythagoras. Now OB 17 square is equal to X square plus 8 square. So from this we can get X. So X is root 225, which is 15 centimeter. So if X is 15, ON, that is 23 minus X, 23 minus 15, that is equal to 8 centimeters. Now since I have ON value, I can now consider this triangle in triangle OND. Again applying Pythagoras theorem, OD square is equal to ON square plus ND square. 17 square is equal to ON, we just figure out it is 8 square, plus ND is what we need to find out. So 289 minus 64 is ND square. So ND is again root 225, which is 15 centimeters. Now we need to find CD. What is the CD? CD can be written as CN plus ND. But since we know both of them are equal, I can write 2ND, which is 2 into 15, that is equal to 30 centimeter. This is one different kind of question, and it generally comes, this model generally comes, you will get one kind of question. Moving on. In the figure, ABCD is a cyclic quadrilateral. It's very clear. ABCD is a cyclic quadrilateral in which angle BAD is 75, angle ABD is 58, and angle ADC is 77. AC and BD intersect at P. Find angle DPC. So this is what we need to find. Alright. So it's a cyclic quadrilateral. So we know that in a cyclic quadrilateral, sum of opposite angles is always equal to 180 degrees. So I can write B plus D is 180. So from this, B is nothing but 58 plus PBC plus D is 77 is equal to 180. So from this, PBC is 180 minus 77 minus 58, which will give us 180 minus 77 minus 58 gives us 45 degrees. Okay. Now, do we have any relation between PBA and DCP? This angle and this angle. See, these two angles are formed using the same chord DA. So they are equal since angle in same segment. They are formed using the same chord. So from this I get DCP is equal to 58 degrees. Alright. Now what else can be calculated? Again here we can apply angle A plus angle C is equal to 180 degrees due to cyclic quadrilateral. So angle A is 75, angle C is 58 plus PCB, which is equal to 180. So PCB is 180 minus 58 minus 75, which is equal to 180 minus 58 minus 75 is 47 degrees. Alright. Now, but we need to find this x. How do we do that? So here we have this angle, we have this angle. So if I consider triangle PBC, angle PCB plus angle PBC is equal to x. Exterior angle property. So what is exterior angle property? That sum of the two interior angles is equal to the exterior angle. So I can clearly see that x is the exterior angle to this triangle. So x is equal to sum of these two. So 45 plus 47 is x. So x is nothing but 92 degrees. It's very easy. It is just that a cyclic quadrilateral, you know that opposite angle sum is 180. So I kept applying that. And then you are here with the answer. Moving on. In the given figure, ABCD is again a cyclic quadrilateral in which AC and BD are diagonals. Angle CBD is 55. Angle CAB is 45. Find BCD. So BCD, this is what we need to calculate. So it doesn't mean that BD is the diameter. Until and unless it is not given, you cannot assume. This is not the, okay, this is the, alright. So how do we solve this? Here we get, if this is 55, this will also be 55 because they are in the same segment, right? Yes. So I can write that angle CBD is equal to angle DAC. Both of them are equal to 55 angle in a same segment. Both of them are forming using the same chord CD. Okay. Now very important thing, it is nowhere mentioned that it is the center of the circle. So if it is not mentioned, you cannot assume it as center and use angle in semicircle. You cannot do that. So since it is cyclic quadrilateral, see, if you don't get how to solve it, keep repeating, keep reading the question. You will definitely get some ideas. Now I saw that it's a cyclic quadrilateral. So since it's a cyclic quadrilateral, I can write angle A plus angle C is 180. Opposite angles are supplementary. A is what? 55 plus 45, and angle C is BCD is equal to 180. So angle BCD is 180 minus 55 minus 45, 180 minus 100, and here we go. 80 degrees. Angle BCD is 80 degrees. So it was very easy. We just found using angle in same segment and then applying cyclic quadrilateral. Moving on. In the adjoining figure, AB is a diameter of a circle with center O. Now this is the diameter. If AC and BD produced meet at E and angle COD is 40, calculate angle CED. So this X we need to calculate. Okay. So how do we proceed? This is the center angle. So whenever you have the center angle, you get that theorem in mind that yes, center angle is double the angle subtended anywhere on the circumference of the circle. So I can write that angle COD, this is my center angle forming by these two and this arc. So this center angle is double the angle subtended by anywhere on the remaining part of the circle. Correct? So here angle COD is double the angle CBD. So 40 is equal to 2 angle CBD. So from this angle CBD is 40 by 2, 20 degrees. It is very important to write the reason in geometry. Here you will mention the theorem. And in these questions I am not mentioning, but it's very important to again write given, what is to be proved. If you have constructed anything, you will write that and then you will start writing proof. These are the 4 steps you need to remember. Now we got this angle, right? Now since it is O is the center, AB is the diameter, I can write that this angle is 90 degrees. Angle ACB is 90 degrees because angle in semicircle is 90. So if this is 90, therefore angle BCE will also be 90, linear pair, right? So if I consider this triangle BCE, I have two angles already found. The third one can automatically calculated by angle sum property. So angle BCE plus angle CBE plus X is equal to 180 degrees. So 20 plus 90 plus X is 180. So from this I get CED is equal to 180 minus 110, that is 70 degrees. I hope this is clear. Now next question. In the adjoining figure, DE is a chord and parallel to the diameter. See, it is parallel, very important. With center O, this is the center. If angle CBD is 60 degrees, calculate CDE. This X we need to calculate, right? Okay. So, alright. Now if you see, this is Z. So this angle and this angle will be equal, alternate angles. These two are parallel lines. This is a transversal. This will be equal to this. So this is x. Okay. Also, I can write angle ADC is 90 degrees, angle in semicircle. So see, only those theorems have been using again and again. So there are just 5 to 6 theorem that you need to keep it in your head, and the chapter becomes very easy. Okay. Now, so we got this angle as 90. So if I find this angle, I can easily find x using angle sum property. So sometimes if you don't get your answers directly, you need to do reverse calculation that okay, I need to find x, I have this angle. If I just find one more angle, I can easily find x. And why is this 60 given? Every detail, every information will be used in every question. Why is this 60 given? Is there any relation between angle A and angle B? Yes. These two are in the same segment. Both of them are formed using the same chord CD. So angle A is equal to angle B because of angle in same segment. Angle in same segment. Now I can directly consider triangle ADC, where angle A plus angle ADC plus x is equal to 180. Substituting the values, I get the value of x. So from this, x is 180 minus 150. So angle CDE is equal to 30 degrees. Very simple. So if I don't get what to do next, I will reread the question and see what information is left. How can I use that information? Or sometimes you will have to do reverse calculation to get there. Next question. In the given figure, PQ is the diameter of a circle with center O. If angle PQR is 65, angle SPR is 40 and PQM is 50, find QPR. Okay, let me just mention them. QPR. So we need to find this. Let us take it as X. QPM, Y and PRS set. We need to find three angles. So PQ is a diameter. So I can write angle in a semicircle. Again, angle M is equal to 90 because of angle in semicircle. Whenever you see that you have given the center, the diameter, angle in semicircle will definitely be used. I've seen in most of the questions. Now, considering triangle PQM, I'm given two angles. The third one can be easily calculated. 50 plus 90 plus y is equal to 180 degrees. Angle sum property. So from this, y is 180 minus 140. What is y? QPM. So angle QPM is 40 degrees. Correct? Now, next, how do we do the next part? Okay, so what do we do next? All right, we can observe that SRQP is cyclic. It is cyclic because all the points lie on the circle. So from this, I can write S plus RQP is 180 because opposite angles are supplementary in cyclic quadrilateral. So angle S is equal to 180 minus 65, which is equal to 115 degrees. So I got this angle. Since I got this, I can consider this small triangle and find Z. So now let us consider in triangle SRP, 40 plus Z plus S, that is 115. I'll just write the value. Plus 115 is 180. So from this Z is 180 minus 155. Okay, so what is Z? SRP is equal to 25 degrees. All right, so we just need to find X. So how do we do this? This is again very straightforward. Since PQ is the diameter, I can write PRQ is 19. Again, angle in semicircle, right? So I have this angle 90. The third angle can be calculated. Same angle sum property. In triangle RPQ, 90 plus 65 plus x is equal to 180. So x is 180 minus 90 minus 65. And here we go, RPQ is equal to 25 degrees. So it was very easy. So if we have two angles, the third angle is always by angle sum property. So always try to figure out, okay, if I find this angle, I can find that. So that reverse calculation will also be helpful. Next one. In the given figure, ABC is an isosceles triangle with AB equal to AC, and a circle passing through B and C intersects AB and AC at D and E. Prove that DE is parallel to BC. So what do we need to prove? DE parallel to BC. So since here we are not given anything, it doesn't matter. It's very difficult. It's very easy. This sum we can just do it on observation. I'm very sure. So since AB equal to AC, I can write angle B and angle C are equal, because if the sides are equal, their opposite angles will be equal. AB is equal to AC, therefore B and C will be equal. So let me take both of them as X using isosceles property. Okay, isosceles property. Now here, since BDEC is cyclic because all the points lie on the circle. So angle B plus angle E will be equal to 180 degrees. X plus angle DEC is 180. So from this I get DEC as 180 minus X. So let me write, this is 180 minus X. Similarly, this angle will also be 180 minus X. Yes? Okay. Now, DEC plus DEA is equal to 180 degrees. Yes, because they both are forming linear pair. So DEC 180 minus X plus DEA is equal to 180. So from this I get DEA as X. Listen carefully, this is X. Similarly, this part will be X. Now here comes the important point. I see that angle C and angle DEA both are equal to X, right? This angle and this angle both are equal to X. And what are these angles? These are corresponding angles. So since corresponding angles are equal, therefore the lines will be parallel to each other. Every time what do we do? Since the lines are parallel, corresponding are equal. But here vice versa. Since my corresponding angles I've proved equal, the lines will definitely be parallel to each other. So this was all on observation. It was very easy question. I hope you understood. Next one. If a pair of opposite sides of a cyclic quadrilateral are equal, so let me first draw a cyclic quadrilateral. So here is my quadrilateral ABCD. A pair of a cyclic quadrilateral are equal. Prove that its diagonals are also equal. Let us join the diagonals. Both the diagonals meet at O. Okay, so what do we need to prove? We need to prove AC is equal to PD. So how do we start this? So since we are not given anything, okay, um, see here we can tell that this angle and this angle are equal because both the angles are formed using the same segment AB, and this angle and this angle are again equal, both the angles are formed using the same segment CD. So let us consider triangle AOD and triangle BOC. Angle ADO is equal to angle BCO. Angle DAO is equal to angle CBO. And DA is equal to BC. So this is given, and this is angle in same segment. Reasons are very important. So I can tell that triangle AOD is congruent to triangle BOC by ASA. Alright, but that doesn't satisfy what we want. So now I got AOD is congruent to triangle BOC. Okay. Can I add this triangle BOA? Can I add this portion on both the sides? So triangle BOA plus triangle BOA, right? Equal quantities can be added, subtracted, multiplied, divided. You know this, right? So now AOD plus BOA will give me triangle BDA. Similarly, BOC plus BOA will give me triangle ABC. Now that I have got this triangle is similar to this triangle, so then therefore I can write AC and BD are equal by CPCT. If you prove the two triangles congruent, all the corresponding parts become equal. I hope this is clear. So we just proved the two triangles congruent. I did not consider these two triangles because we cannot find the three things that are equal. So which is why we considered the smaller triangles and added the common triangle to both in order to prove the bigger triangles congruent. Now moving on to the last question. In the given figure, ABCD is a quadrilateral in which AD is equal to BC. Angle ADC, okay, angle ADC is equal to BCD. Show that ABCD lie on the circle. Okay, so basically we need to prove ABCD is cyclic. This is very important, and here we have constructed. What did we construct? DE is perpendicular to AB and CF is perpendicular to AB. So I'll tell you why did we construct. So if we don't construct, I cannot prove that the points lie on a circle because there's no information given. So my main aim here is to prove angle A and angle B equal. I need to prove this. I'll tell you why. Because if I prove A and B equal, C and D are already equal given. As we know, in a quadrilateral, A plus B plus C plus D is 360, angle sum property. So A and plus B I can write 2 angle A, C plus D I can write 2 angle C. So from this I get A plus C is 180. So if I prove that opposite angles are supplementary, then the quadrilateral is cyclic, right? So main thing I need to prove A equal to B. So which is why I constructed the perpendicular line so that I get these two small triangles, that is AED and triangle BFC. So if I prove these two triangles congruent by CPCT, I can tell that angle A and angle B are equal. So if angle A and angle B are equal, you know what to do next. So here I have done reverse calculation. There was nothing given. So I thought, okay, what should I prove so that I can get there? right? So I wanted to prove A equal to B, but that can be proved only if I have triangles. So now this is your homework. I want you to prove AED congruent to BFC. Once you prove them congruent, angle A will be equal to angle B by CPCT. So if you get this, then here is your solution. I hope these questions are clear. These are very important and most repeated questions. So if you are thorough with these questions, I know you will crack the circles chapter, very sure. So please check my previous video where I have explained all the theorems properly, all the important points that you need to remember, and then watch this video. You will find it super easy. So yes, see you in the next video. Thank you. Please share, like and subscribe the channel to get more updates.